We'd like to welcome everybody and thank you for coming tonight. This is a really good turnout for us. We're really looking forward to this presentation because science and engineering are going to become much bigger parts of our exhibits and our program. So I'm going to bring our education director up, Joe Kent, and he's going to give the formal introduction today. Thank you for coming.
Good evening, everyone.
Good evening.
Everybody enjoying their evening so far?
Yes,
Good.
sir.
All right, everybody hear me okay?
Yes,
I decided maybe not to do a microphone. So, our speaker tonight, Leonard, Gentile, is currently Information Systems and Global Solutions Fellow at Lockheed Martin. He's a well-respected drone and counter-drone expert. And tonight, he'll be discussing what is being done to bring order to the proliferation of unmanned aerial vehicles. And he's also going to be talking about the different categories that are out there, what's being done to protect people. You know, the big concern, obviously, privacy, but also other things that he's going to be discussing as well. And we're also just very honored to have him here and for being working with Lockheed Martin on this, bringing out such a, like I said, respected person in the field. And without further ado, if you join me in welcoming Mr. Gentile with a round of applause.
Thank you for the introduction. Good evening, everyone, and thank you for joining me this evening. I know it's a Saturday. I know some folks who work during the week and they came back on Saturday. I really, truly appreciate it. Yeah, as he mentioned, my name is Leonard Gentile. I'm from Lockheed Martin. I have experience in the United States military and basically in the intelligence field for the past 30 years. And I took, with the group that I work with in Lockheed Martin, we took a somewhat different approach to some of the issues that are currently surrounding the drone, I'll say problem, carefully, the proliferation of drones, and that's going to be the emphasis of our discussion this evening. So with that, let me turn my on. Do a click or just before I came out here? Okay. So what I've done is I've broken up the presentation into a couple of different categories. First, we're going to define drones. We're going to talk a little bit about what some of the issues around drones, and then we're going to talk a little bit about how we actually are managing the threat. And then two different categories. The first category is we're going to talk about what do you actually do to detect and track drones, and then we're going to talk a little bit about some of the interdiction techniques. What if you actually have to engage a UAV that's encroaching? I'll say mostly from a commercial civilian infrastructure or from a military perspective, because taking this matter into your own hands as a civilian in your backyard is not a good idea, and I have a little video that shows that as well. And then I'm going to spend some time talking about a capability that I came up with at Lockheed Martin called Drone Fence, which is an approach to working the UAV issue. And then some closing thoughts. I'll try to wrap this up in about 45 minutes, and we'll take some questions at the end. First, let's just start by defining a drone. Effectively, a powered aerial vehicle not manned by human operators. So essentially, if it flies and it doesn't have a person on board, it's a UAV. It's mechanical, right? It can fly autonomously, or it can be commanded from the ground with a remote control. Lots of different names, what they call them: an aerial vehicle, drone, unmanned aerial system, remotely piloted aerial vehicle, remotely piloted aircraft system, radio-controlled aircraft, model aircraft, etc. But if it flies, it's a machine. It flies. It doesn't have a pilot on board. It's a drone. We're going to be focusing, what I focus on exclusively is the smaller class of UAVs, which is in this area called this Class 1. So basically this is from a U.S. Department of Defense model. And what's been done is they want to classify UAVs into various categories. This is generally accepted and adapted into, by other countries. And other environments as well, but Class 1 through Class 5. The basic categories are defined by what is the weight of the platform when it takes off, what is its altitude, and what is the speed at which it could fly. And this goes all the way from a Class 1 UAV which could be the size of your fingernail, up to something that is up to 20 pounds. It can fly up to 1,200 feet, all the way to the gigantic picture, silhouette picture of that happens to be a global hawk, which can fly in excess of 30,000 feet, can fly for many days at a time, can take off in one country, perform operations, or the other side of the world, do its mission, come back. My focus is not the large aircraft. I work primarily with commercial companies, commercial entities, particularly international airports. They're not government agencies. They're not fighting a war overseas. So they're working the issue where they have a civilian operation, they have a civilian critical infrastructure, and they're integrated in a city where there's lots of other civilian infrastructure around them. So they have a very, very complex, very sensitive problem. So I focus more on the Class 1 side of this, the drones that you can buy on the internet, that you can buy in the mall. There are many millions of them available worldwide. We're seeing them all over. Their size and their availability is what's really contributing to the issue overall. At some point when it comes to actually working with drones and having to do something about drones, if they get to a certain size, weight, and altitude, it's clearly not a local law enforcement issue. It's not an individual's issue or even an airport's issue. It becomes an airport's issue. So that's a different problem and part of a different discussion. So the challenge, as we know, it's exceedingly easy to buy a drone. Any one of us can buy a drone for $50, $30, $500, $600, $700 now. Gets you a UAV that's very capable. I've been working with UAVs for a long time. Even in my group, we bought a UAV 6 years ago. It was $27,000, and it took specialized training, 2 people in Canada, a week to learn how to fly it. And now you can do better with a UAV for $900. You could fly right out of the box. It's just going that fast. And as we talk about here, they were expecting more than 1 million drones were purchased by Christmas of last year. There's drone flying competitions. There's been so for many, many years. You can just buy them up on Amazon. You see the exponential growth year over year on drones. So the rate of growth of the UAVs or drones year over year is growing exponentially. The affordability or the capability is converging very, very quickly. So, as I mentioned, the UAV that cost $20,000 to $30,000 was out of reach, except for basically everybody, except for the very, very eccentric, exceedingly wealthy individuals who had that kind of money to play with. Now you're putting very, very, very capable platforms in the hands of basically anybody with $500. So its capability over affordability is converging quickly. And basically the pace of sales and the technology is like everything else. So this is moving very, very, very fast. Local law enforcement, federal government, civilian corporations, everybody's working as fast as they can and as diligently as they can. But the growth of this is outpacing all efforts so far to enforce reasonable regulations. That's the primary contributor to the issue. Lots of goodwill. Not all UAVs are bad. Obviously, lots of UAVs are used for exceedingly good purposes. But there's just the more UAVs you put in the air, the more UAVs you have to actually wade through to figure out which ones are on doing good missions and which ones are actually just hobbyists and which ones are actually doing things that are somewhat more nefarious. So I've been doing a lot of work with global airports, and unfortunately, we've seen that the growing number of incidents where UAVs have encroached way too close to commercial airliners. Recently, and this is the first one that's made a lot of public news lately, but this is the first incident where a drone actually hit a commercial jet airliner, as announced worldwide, of course. This was a British Airways jet flying from Geneva to Heathrow, and it is sort of underscoring some of the problem. One of the issues that we're having here is that it's very, very difficult. We're getting a lot of indications that there's UAVs, but they typically don't. We get a report. That's why we see flashing green and blue lights, and a pilot will call in and say, "I see flashing blue and green lights," and then it was never detected before the lights were seen, and from that point we really couldn't actually find where the UAV was. So we have to do a better job at actually pinpointing when the UAVs are flying close to planes or any other critical infrastructure, and that's what I've been focusing on. But we're just seeing week over week, month over month, incidents where UAVs are coming very, very close to airplanes, flying over airports, flying too close to airports. It's growing and growing and growing. And this is something that we were afraid it was eventually going to happen, that a UAV was going to hit a plane, and apparently it did. Thankfully, the UAV did not go into the engine. There's to the best of my knowledge, the jet engine manufacturers have not tested putting the UAV through an engine yet. There's some modeling that was done by a couple of universities that predict what possibly could happen, so there's lots of discussion. There's mostly in academic circles right now, but this is potentially an issue. So I have a little video here to sort of underscore this problem. This video is available anywhere. This was an example of, this is in Turkey. This is a amateur drone pilot. He put a UAV up in the air just aside of the Turkish airport, and within a matter of seconds he went from ground level to way over 1,000 feet and actually straight up over taxiway. This video is 12 minutes long. I only put a couple 25, 30 seconds in here. He gets even more aggressive. He flies directly over approaching aircraft and departing aircraft. This is pretty scary. This was obviously a very, very dangerous thing to be doing. But we just sort of, one of the things I wanted to underscore in the video is just from, we only played this for 25 seconds. We saw that from takeoff to directly over the runway. We were there in about 10 seconds. That's pretty scary. The actual Mexico, there was an airport in Mexico that actually flew some beautiful imagery over their airport. One of their airports is actually online as well, doing it. But that was if you happen to be looking for some videos online, you see the one from Mexico. That was not a road drone issue. The actual airport commissioned the flying of that for marketing for the actual airport itself. But again, maybe beautiful photography, but really, really, really dangerous. So the FAA is actually setting the United States FAA is actually setting their standard. There's a lot of words here, but they're setting their standard worldwide for trying to get out in front of this with reasonable regulations. And I'm just going to gist over some of them, but one of the most important things that we all need to be aware of as drone either enthusiasts or pilots. As of December of 2015, the FAA now requires the owners of all small unmanned aircraft or drones weighing between 0.55 and 55 pounds to register online before taken to the sky. So basically, almost any of these drones that are the most popular ones that you're seeing being used today and that you're buying for yourself, your children, or what have you, all of them need to be registered. That was the law as of December. The FAA has come out multiple times with regulations around drone flights. A lot of them are quite practical. I just gisted here and get some of the specifics of the numbers, but keeping your UAS in eyesight at all times. Do not interfere with other aircraft operations. Do not intentionally fly over unprotected persons or vehicles. Contact the airport control tower before flying close to the airport. Do not fly in adverse weather conditions. Don't fly under the influence of alcohol or drugs. Ensure the operating environment is safe. Do not fly close to or over critical infrastructure. Follow all local laws and ordinances. And you cannot conduct surveillance or photographs of persons where there is a reasonable expectation of privacy. So if your neighbor is inside their stockade fence and they're sunbathing by the pool, there's a reasonable expectation of privacy. You cannot fly over there and photograph them. That's one of the famous incidents that we've seen in the local press. And that it usually has a bad outcome. FAA, United States FAA set the standard. The Civil Aviation Authority in the United Kingdom actually filed suit. And this is a fun little cartoon that one of the local papers in London actually put together. But they followed suit, defining what the UAVs are. Should be visible at all times, no more than 1,640 feet from the visual plane. At no more than 400 feet in altitude. Never fly closer than 164 feet from people, vehicles, or buildings. And the specificity is kind of fun here. Forbidden to fly within 150 meters of gatherings larger than 1,000 people. I don't know why it's okay to fly gatherings smaller than 1,000 people. And then using drones for professional purposes requires permission from the CAA, and it's a very important one. Because we see a lot of companies, whether they're photography companies or whether they're engineering firms or architects or construction firms using UAVs, and everybody has to be on board. If you're using a UAV issue of business, they have to be registered with the corresponding agency. That's true in the United Kingdom. It's also true in the United States. So that was just sort of setting some terms, right? So I wanted to define what a UAV was, sort of tee up the issue, kind of using the airports as the focus. I use the airports as somewhat of the thematic, because it's been some of the work that I've been doing. I use that as a thematic, later on. And then I want to talk a little bit about the regulations. So now in the next two parts of the presentation, I'd like to talk a little bit about some of the techniques that are actually used to detect drones. Again, the focus of this presentation is more about what are you doing about drones that are not, flying in an authorized way. So effectively, rogue drones is a rogue problem. So this chart actually talks to two parts of the issue, right? So there's the drone itself, which we're classifying as a vehicle, and then there's the controller. Now you can use techniques to detect both the drone in flight as well as the controller. Obviously, it's very useful to detect the controller if you actually want to intercede with the controller to actually stop it from controlling the vehicle, or you want to find the guy who's actually, or the guy or gal who's actually flying the UAV, which is something that the police are very interested in as well. In this part of the presentation, we'll focus on radar, video, UAV signals, signal emissions, or radio frequency, and also acoustics. And when we think about this sort of problem, and I came to this from a classical military and intelligence perspective. If you're going to actually work the problem of UAVs as a threat, you first have to know that they're out there. So you have to actually detect them. And once you detect them, then you have to actually track them. So you got to know where they are on some consistent basis. And then ultimately, what you would like to achieve is you'd actually like to characterize specifically what UAV, what the make and manufacturer of the UAV is. That's not so incredibly important for some interdiction techniques, but if you wanted to do some onboard computing techniques where you can actually interact directly with the vehicle in flight, then knowing what UAV is out there is extremely important, because if you know the UAV, for example, you minimally know what frequency they happen to be operating on. So we'll talk about radar, video, UAV signals, and acoustic signatures in this next section. Okay, so the first technique that we're looking at is a radar technique. I talk about radar first because radar, for what we're doing today, radar has been the technique that allows us to detect UAVs at the most extreme ranges. A lot of these other techniques, the UAV has to be reasonably close. Some of the customers that I'm working with are trying to, or have the requirement to detect UAVs out to about 10 or 11 miles. So at 10 or 11 miles, acoustics, video, a lot of that just flat out won't work. But there are a few companies around the world today that are making special built for purpose radars that have a reasonable chance at detecting UAVs out to that range. So just to sort of highlight the problem, we'll just talk a little bit about how radar actually works. First on the ground, you have a radar transmitter that sends a pulse of energy transmitted from the radar antenna in a particular direction, and sometimes you have multiple, depending on the size of the radar, it actually can cover quite a spectrum of, or quite a bit of distance. We have multiple radars working together. But just consider that you have a radar antenna that's shooting signals into the air in a certain direction. As the energy wave propagates through space, it spreads out and it loses power as the range increases. So that's why when the further away the actual platform is, the harder it is to detect, because the power of the pulse that's been sent out actually weakens and propagates over the distance. At some point, if there is something that is out there to be detected, or there is something that's flying within the plane, the energy wave will hit will hit the platform, and some amount of energy bounce back towards the radar antenna based on the object's radar cross-section. So the radar cross-section is the actual area of the object in space that actually the energy hit and actually caused the energy to bounce back towards the receiver. So that reflected energy propagates back through space, spreading out and losing power, and ultimately the reflected energy from the object is received at the radar antenna. If that power is strong enough, then the object is detected. So that's just basically, I know there's some engineers and PhDs in the room, but in a very sort of ABC way, that's just kind of the basic ABCs of how it works. We're sending energy out. If there's object in our field of view, it'll hit it. The further out it gets, the less likely is that we're going to hit it. The energy comes back over space. The problem is it's losing energy the further out it goes, and it's losing energy as it comes back. That's what the challenge is. So obviously, the bigger the thing is that's out there, the more likely it is that you'll hit. So the radar cross section that we just talked about, that's sort of like the area that you're actually hitting in space. But if you consider from just an airplane's perspective, if the airplane banks like this and you have the broadside of the bottom of the airplane, its radar cross section is going to be quite a bit larger than if the plane is actually coming in like this and it's nose down and your radar is going like that, because not only is the radar cross section going to be just the circumference of the nose of the plane, but it's also going to be at certain angles where a lot of that energy is just going to bounce off the front of the nose. So if it disappears, but you see, if we take the plane away and replace that with a drone, now the problem becomes that much more. So if you consider, we talked about that radar cross section with that little example. So a jumbo jet airliner would have a radar cross section of 100 meters squared. A drone, like the typical drone you would buy on Amazon today, is 0.005 radar cross section. So it's basically it's like the equivalent of hitting the broadside of a barn out there, or something smaller than a tennis ball. But it is the advancements in radar are spectacular. These companies are actually producing these systems that actually can truly do this, and that's why we are looking at radar as the principal technique to actually detect drones at range. So a lot of my background is working in video. So we're doing a lot of work with video. So if you consider multiple systems working together, and if you really want to actually work the drone problem, especially lots of drones in the air at great ranges, you're ultimately going to have multiple systems working together. So consider if you had a radar actually detect a drone at a great distance. When the drone comes a little bit closer, you might be able to hand it off to another system. In this case, video would actually be a good technique. We have very high power cameras that we work with. They're military grade cameras that can do surveillance of UAVs and other platforms on the ground or in the air at great distances. So we can actually have powerful high definition video cameras can be trained on the horizon to actually automatically detect and track movers in space within their visual field of view. There are advanced processing techniques that, given the actual object that has been found in the field of view, can autonomously be able to determine what it is, whether it's a jumbo jet airliner or a bird or a UAV. And there are some techniques that are being worked on right now to specifically type a UAV, as well as make a manufacturer. This is basically in pixel space, just by automatically processing pixels. We can have multiple cameras, because one camera is only going to have one sort of limited field of view. If you get to a camera that has a great field of view, and you're talking about cameras that could cost $2 million as opposed to $100,000. So maybe you have multiple cameras that are somewhat less expensive you want to string together. So then we can actually have multiple cameras work together. You take the result of all of this processing, and then you put it together in a high-end situational awareness. So you think about your Google Maps. We can do an implementation of Google Maps where we're actually defining the area that we're working with for a particular customer, and then we can define the areas that they're principally concerned with as a volume. And then if the UAV actually encroaches within a volume that we define in 3D space, then we can actually work some other systems that actually register it as a threat and warn the correct people that there's UAV that's encroached. But this is a very important technique when, especially if UAVs come much closer. Or get closer to an objective. Another technique is a radio frequency technique. We were having some conversations, out there. Lots of manufacturers of UAVs all over the world. They use lots of different frequencies and frequency ranges. A common one is 5.8 gigahertz and 2.4 gigahertz Wi-Fi frequencies, frequently used for control of video transmissions. Drone command signals are transmitted from the controller to the platform, and then the platform will send video down, on its downlink. We can use multiple receivers on the ground to actually detect these frequencies being used in space. And the more receivers you have, the more you have the ability to actually triangulate the actual object, in space that's actually broadcasting on a certain frequency range. Unfortunately, when it comes to the UAVs, it's very easy now to acquire a UAV that just basically flies without the commanding of the controller. You can basically, now you can just use your iPad. You can just create a flight plan for a UAV now. You just put a couple of points in space that called waypoints, and you can just send it off on its way, and it goes, flies a mission, and comes back to you. So in that case, there's no direct communication from the ground to UAV directing it where to go. It's flying on its own. So it's only just basically using its onboard GPS to know how to fly on that pre-programmed flight plan. So in that case, this technique wouldn't be very useful. And again, it underscores one of the reasons why you need multiple techniques working together to have any chance of detecting UAVs at range and then tracking them and ultimately interdicting them. Typical RF techniques would work in the 1500 range, 1500 foot range max. There's a lot of different atmospherics comes into play, the strength of your antenna. There's a lot that goes into it, but generally speaking, 1500 feet. Again, it doesn't get you anywhere near the 10 miles that we were talking about previously. So before there was radar, acoustics has been a technique since the beginning of time. When we were putting planes in the air, we were trying to use acoustic techniques and also binoculars to detect aircraft in space. These devices, I understand, actually worked, believe it or not. And there's a whole lot of fun pictures if you want to look online about this. But acoustic techniques have obviously come a very, very long way. UAVs make very, very distinct audio signatures as they fly. They tend to sound like a weed whacker, but there's a lot more distinct than a weed whacker from a computing perspective. We can exploit the sounds UAV makes. We can create a unique audio signature for each type of drone. So we can actually put a drone out there and we can profile a drone. We can actually capture its acoustics. We can profile its acoustic signature and then catalog it. So then when our system hears it the second time, it knows exactly what drone it is. It is ideally suited to work in conjunction with other techniques. I've said that a couple of times, but this is, especially if you get into a closer range, this is a really great technique because the actual precision that you have with acoustics is pretty fabulous. And we in our company have had some great success working even with a lot of ambient noise. So you think about the airports, so how does that work with airports when you have planes and land and take off? It's really not a problem. Even with all that noise, it still works. The basic graph on the bottom just shows that above some noise ceiling, that the drones have a very, very distinct frequency characteristic. It's the modeling of this frequency characteristics in the spectrum that allows us to actually typecast a particular UAV make and manufacture. this again is very, very powerful and important technique when you want to actually take some really advanced interdiction methods to actually engage them. So that wraps up the drone detection. There's other techniques out there for this. I just wanted to hit some of the main ones and underscore the main point that we're really using radar to detect them at far off range. And then really, if you're going to do this in an operational context, you really have to have multiple techniques working together. So in this section, I'm going to talk a little bit about interdiction techniques. I have to say, for the customers that I've been working with, the airports, this doesn't come into it. Interdiction is not on the table. Why is interdiction not on the table? Because airports do not have the authorization to shoot UAVs out of the sky. They just flat out don't. You guys don't have the ability to shoot them out of your backyard. Airports don't have the ability to take them down, over their airports either. So that is a real, true issue. You're seeing a lot of providers come in the market today with different, techniques for engaging a UAV. But if you really think about it, who really has the authority to take a UAV down? And if you're willing to do it, what are the legal ramifications? You take a UAV out of the air, it's going to land somewhere. It's somebody's personal property. And if it lands on something, that you don't want it to land on, like a moving car, and it's a mess. So the agencies that I work with, they don't get anywhere near that risk. They have a team of lawyers that won't have been there. So interdiction is good in some cases, but very, very few. So we'll talk a little bit. I'm not negative about drone interdiction, but there is a place time, obviously, where in a field of battle overseas, you're working in Iraq, places like that. I mean, obviously, you can do this all day long, but when you control the ground, you control the airspace. But we're not going to put laser systems around the museum. I mean, we're just not going to. Speaking of laser systems, having a fun video. So this is obviously a real radar laser system. It's a small company in Jersey. It's pretty scary looking, but. So this is a UAV. This is a system that has automatically tracked the UAV in its field of view and shooting a UAV in flight, and it takes it down. You see, from acquisition to on the ground, it was 3.3 seconds. I will tell you, my opinion is it probably was shooting the laser at that thing in the 10 kilowatt. Very, very powerful. In order to take it out and put it on the ground in about 3 seconds, that laser, had it not hit the UAV, would have went off for a long distance. And if it didn't hit the UAV, it was going to hit something else. So, having said that, so they can be highly precise. They can be configurable. You can toggle them as far as the power is concerned. And they obviously can be effective, but they are quite expensive, and they may result in significant collateral damage. And where does the flaming wreckage land if you actually hit? So that is something that you definitely have to consider with these. They're kind of cool, but it's probably not realistic except for a very, very, very small set of circumstances, and probably military circumstances, in my opinion. Another interdiction technique is projectiles. So this is one of those cases. This is a video where a particular individual was putting a lemon foam on his property. Someone was actually doing surveillance and decided to shoot it out of the sky himself. And he's got the perspective from the UAV. Because he actually was able to get the video from the drone as well as the ground, some people suspect that it was a publicity stunt for his lemon farm operation, but it still underscores the effectivity that a shotgun should have in certain circumstances. But there's several. But I'll tell you, every one of these that has hit the press has resulted in somebody getting visited by the police, because you're just not allowed to do that. So effectively, the projectile is anything where you're walking from the surface where you're putting the projectile up in the air. Weather conditions could impact. Shooting anything from the ground up into the air could cause a significant public perception and a particular legal problem, and collateral damage on multiple fronts. What else are you possibly hitting in the sky? And where does debris scatter once you hit it?
I can appreciate that, but having been a public information officer on the lake fire on Big Bear, California last season, and we had to fire escape the containment lines, and we had to down all our firefighting aircraft because the drone was in the area.
Yeah.
29 Palms is there, and I had an awful lot of Marine Corps retired scout sniper teams offer to post on the hillside. They've already worked out mapping just to watch for the rest of our operations.
I would say that
So
was-
it's not that far off possibility-wise.
Oh, no, this guy did it with a shotgun. I mean, you running out of the front facades. Marine sniper definitely can do it. And there is 100% good use cases for that, and you just named one of them. I couldn't agree with you more. I'm just advising that if you're in your backyard, and there's no flies and drone over your backyard, it might not be the best course of action. But, up to you. Another technique is a laser technique. These actually could be quite effective as well. If you have a UAV operating in the air, so you can illuminate the drone so it can help actually track it. You can block its visual sensors, so a lot of people put the drone in the air because they're trying to conduct some sort of a surveillance operation of some sort or another. So if you dazzle the actual sensor on board so they can't shoot the video anymore, there's no reason to fly it, and it typically would go back. And you could just sort of as a warning, hey, you know what, you are being watched. So the thing that you're trying to do that you were being, seen doing, we see you doing it. It could be very dangerous though. We've seen some scary incidents, and I'm from New York, and a couple of them recently where somebody was in Long Island and they were trying to blind pilots flying to and from Kennedy Airport from a park in Long Island with the laser. It's very, very dangerous. So this could be a very effective, very low cost technique. Could result in a favorable action, but you have to know for sure that there's no commercial planes flying in the area. And again, something a civilian most definitely cannot do on their own. Okay, so we'll have a little bit of fun with this. So drone interdiction, this is a physical intercept. So this is mid-air intercept and capture of a drone. And we'll look at the first one. And in this case, this is a small company in Europe, and they've developed a totally integrated system in a bazooka that puts a projectile in the air, blasts apart, does a Spider-Man projection of the net on the UAV target, captures it and brings it to the ground, and they can reload very fast. Shoot out another UAV, boom, catch that one. And then they have a parachute to actually safely bring it to the ground. And we've worked with several agencies, and one of the things that they're quite interested in is they'd like to actually retain that platform, intact. If you just blow it up in the sky, it's good for nothing. So from a forensics perspective, actually having the UAV intact is a very good thing. We keep the camera, we keep the platform. We can learn a little bit more about the person flying it potentially. The next video. This is really cool. This is a company that's working on an attacker UAV that can do air-to-air combat, with a net, so they can fly on an objective and shoot a net from one UAV onto another UAV. So again, that's actually very interesting. Pretty finite result. As soon as those propellers, as soon as the net engages those propellers, that UAV is definitely going down, and it's going down right where you hit it, which again can be effective because some of the techniques that you can use, you may not know how much further the UAV may fly off and where it land when you're actually on the UAV like this and you're putting a net on it, you pretty much determine exactly where it's going. Because as soon as the propellers get hit with that net, that thing is going down. So that's actually kind of fun. But again, it's air-to-air net deployment. It's basically close range. I think the effectivity on that bazooka gun is probably in the 300, 400 feet. I was working with another university, we were working on a similar system that was ground launched, and we were trying to get up to like 1,000 feet or something, but it's basically close range. And again, because there's some more precision from an air compact perspective, you know, that collateral damage is somewhat limited, and forensically, you actually are keeping the platform intact and up there with the parachute. You're keeping all of the projectiles. If you didn't see with this technique, every single part of the projectile is actually all tethered together. So the whole body of the projectile, the net, everything is all part of one package that comes down to the ground, as part, you know, with the parachute. I'll go a little bit faster through this. There's some signals techniques as well. You know, we talked about GPS before. So the UAVs use GPS to know where they're at relative to the controller. So if you can actually feed the UAV with inaccurate GPS coordinate information, that's going to incorrectly calculate its own location, it might be possible to actually steer it to where you want it to go. You can jam a UAV. So if you actually disrupt the connection between the controller and the UAV itself, the UAV takes some very predictable actions, but it's not the same for every manufacturer. Some of them will loiter in place, some of them will bring itself to the ground. Others will actually go back to the controller and hover over the controller, like the person with the controller. That's kind of good if you want to arrest them. We've done some work with UAVs where we've done, you know, where if you've broke the connection, the UAV takes off in an unpredictable direction and just keeps on going, and then it goes back. There's other advanced techniques where you could possibly take over a UAV. You can get on board a UAV, and you get on board its computer, and you can basically tell it to land as well. So animals. Every one of these pictures is a moment in time where somebody who was flying a UAV to do some nature photography. That's the moment in time before it's a cheetah, a hawk, a Labrador, and a ram actually took the UAV up. So those are all videos online. That is actually the moment before the UAV went down from those particular animals. This is actually in the Netherlands. The police are actually experimenting with falcons to capture UAVs in air. They like to keep their prey, so it's hard to get the UAV back from them. The video continues, and the falcon is kicking around the ground, and everything is going to get it back. So you see it's kind of hiding in the corner there. So I'll go quickly through this next thing. In Lockheed Martin, I've been working on a capability called drone fence, and it tries to bring together a lot of what we've been talking about. So a lot of this is, you know, you want to sensor UAV, you want to classify it, you want to visualize it, you want to track it, and then you want to disposition it. So we're, you know, from what I'm doing in my company right now, and the drone fence capability that I created with my team, we're looking at this problem from the front to the back. You know, we have to work with the customer. We have to know, you know, what really is the legal remit for a particular customer. Is it a military organization operating overseas in an area where, you know, where we're fighting in a military conflict, or is it a civilian operation like an airport? So you have to understand what are the legal parameters that we're operating in, what are the requirements of the customer, what are all the other environmental factors, and that's how we work with our customers from the ground up to understanding, you know, what really are all these parameters, what are these requirements, and then build to purpose the solution that actually matches their needs within the legal parameters in which they can actually operate. And this coming up here is just an example of how we are actually working with a customer from an airport's perspective. So one of the things we did over the course of one day is at the top left, from an airport's perspective, this is just modeling all the arrivals for a given day. So, you know, we're just actually understanding what really is the area. In orange is the density of planes arriving at a particular airport. They line up real nicely. On the bottom left is all day long, that's the density of planes on departure. So we can just tell at a gross level that planes on departure create a somewhat more complicated challenge than arrival, because there's a lot more diversity in what they're doing once they get in the air, based on whether or not they're taking off to the east and heading out west. Based on if they're a smaller airplane, you have a big Airbus A380, they can take up to 18 kilometers to get up to over 4,000 feet in some cases. So they fly off for great distances before they go out to range. So there's a lot of different things to actually consider. So then what we'll do is we'll consider the problem, and then we'll start doing some geospatial analysis. And see the picture over here, and the first picture with the graphics is just from an arrivals perspective. Start to understand, okay, if planes on arrivals line up around 6 kilometers away from the airport and are on a 3-degree decline, what really is sort of that sweet spot, that defines the area that they're normally operating in, on arrivals. And once you actually understand that, then you start to tailor solutions to make sure that where they're at their most vulnerable or where they're most likely to be, that's where we're really going to focus our systems to make sure we do our detection. And then once you actually do all that analysis, then you start looking at it from a 2D perspective and say, these are all the max ranges that we would need to provide the protection, for, in this case, an airport. So when we work with customers, situational awareness is very important. So we use high-end globe visualization so we can actually model facilities and moves in space in 3D, and also 4D, which is basically track propagation, which basically says you can model lat, long, and altitude, and the fourth dimension is trying to predict if a UAV is here, where could it possibly go based on its track history. And we work with customers in decision support, so we actually do what I just talked about. What are the legal parameters? What are their requirements? What are our requirements? How do we actually model the systems to work within their environment? And then the decision support is how we actually escalate through their procedures to actually put the decisions in the customer's hand, so they actually know what choices are available to them, based on the threat. And then we work across multiple sensors so that we can actually figure out how to have those sensor packages working together, as I mentioned, and then tailor them again to meet the customer needs. And then we have actually field personnel, whether they're security personnel, whether we're working with local law enforcement. How do you tie the whole operation together from your customer, with their security personnel, with the local law enforcement, within the federal guidelines, and pulling this all together? What I'm trying to underscore here is that this is a complex problem. This isn't just, putting a gun on, in your front yard and, shooting UAV out of the air. This is sort of a big deal. It's a complex problem. It takes a lot of consideration and a lot of work to actually get to the point where we have a truly viable operational system deployed and doing the job of detecting and tracking UAVs. So just some closing thoughts. Like we talked about before, the commercial drone market is growing very quickly. Low-cost, highly capable drones are now affordable to the masses. Professional use of drones supporting civil needs is very positive and growing fast, and we're seeing that. So we have to work together to make sure we're protecting that and protect that advancement, whilst we're actually working on the mission of where drones are being used irresponsibly. And then, as we know, online retailers are actively pursuing using drones to do things such as deliver packages, and we at Lockheed Martin are very, very active with that as part of a consortium called the Unmanned Traffic Management capability, where we're working with regulators and with companies around the country to make sure that we can do this in a smart way within regulations. If you don't use them within regulations, irresponsible use of drones can pose a real threat. Our law enforcement is working as fast as possible. Existing systems, sensor systems working on their own are usually incapable of detecting, drones at range. That's why you need some built-for-purpose systems and advanced systems that work together. Most interdiction systems are not viable due to collateral damage concerns. Drone manufacturers have been developing solutions to limit the risk of dangerous use of drones. One of the things that they're doing is they're doing this fencing, this geofencing thing inside the UAV. So if you sell drones, and like for example, like every airport will be programmed into a drone. So your drone, where you can try to fly it next to an airport, and the drone just will not fly. It's built in the software. So there's several UAV manufacturers that are doing that. It's a very responsible thing to do, and we're going to see more of that. Again, in the part of the Lockheed that I work with, United USF Drone Fence, we are working, taking an enterprise view of this problem, assessing it from a real threat perspective, and providing terrible solutions. But ultimately, the role of the drone operator to follow all laws and guidance, register drones, and fly responsibly is key. And that's sort of the last message and closing thought that I want to provide to you today. Thank you. That's all the information that I had in the slides. I'm about 5 minutes over, but I'd love to take any questions if you have them. Sure. Sir, your hand first.
Just the
registration process include some kind of identifying signal within the drone where it can say, I'm registered, and somebody can pick that up? Or would that have to be probably not?
So you're actually talking about an interesting concept. Part of the unmanned traffic management work that we're doing does call for, in this case, what would be the professional use of drones, to say your online retail store to delivering packages. You know, one of the things they're going to do is they're going to define operating corridors that are approved for the purpose of delivering packages, and all the UAVs that have on board have to have a commercial transponder. This is, as you say, that's going to be making sending out its position on a regular basis, so we'll be able to track them from ground operation back to ground. It's a very straightforward thing to do, and that is an absolute requirement for all of the things you're hearing about from using drones for these purposes.
Are most of the manufacturers here in the U.S. or offshore?
Yeah, no, that's another great question. A lot of the manufacturing is done overseas. Obviously, as you reasonably can expect, obviously China makes a great number of UAVs. There's a lot of UAV manufacturing done in Europe as well. But it underscores one of the issues that I think you might be getting to, which is if we're wanting UAV manufacturers to get on board to do things such as geofence, so they're not the program of the fire critical infrastructure requires the manufacturer to be on board. So it'd be easier to do that if it's a Nevada-based company than if it's a China-based company. So you're 100% correct.
Okay,
Thank you, sir. I'm sorry, a lot of questions. I think I saw your hand first.
What about the opposite of interdiction protection? You're talking about the delivery things. What's to stop your neighbor from blowing your package out of the air if it tries to land?
How do you protect your UAV from?
Yeah, let's say Amazon starts delivery. How do they protect theirs from the guy with the shotgun?
Frankly, I don't know. I mean, the shotgun is a pretty last resort sort of situation.
Or like he's talking about with the drones over the fire scenes, because people just want to see what's going on. Is there a way to protect a legitimate drone where they're surveying the fire? Is there anything in the works to protect the legitimate use of drones?
Right, so if somebody's actually going to shoot at a UAV, I mean, if you see it in your visual plan and you're going to shoot at it, it's going to be hard to actually, obviously, if you're aware of the environment and you have some awareness of trouble on the ground, you potentially could be operating the vehicle in a way such that you might be able to avoid the shot. And if somebody's actually trying to use one of the other techniques that we talked about, like a radio frequency technique, you can encrypt the communication between the controller and the UAV so that it would be hard to actually interdict because the actual communication is encrypted. So there's lots of different things that you can do. I mean, the projectile thing is kind of a hard one, but for a lot of these other things, there are most certainly techniques that can be used to protect it. But, like I said, the public awareness and, I think this will become a lot more accepted and acceptable, and these online retailers are going to have to fly. It's going to just think about the post office delivering packages to your house. They drive their trucks up and down your road in the same way every single day, and these are going to be air corridors in the same way. I mean, these drones are going to have to fly in the same way. They're going to come down and drop packages, and they're going to go about their way. So that's an answer. Another question? I'm sorry, go ahead.
On one of your slides, you had EMP as an introduction technique, but you didn't discuss it. So I wondered whether you're protecting against that sort of interdiction from someone else or using that.
So I had signals on there, but I specifically didn't talk about electromagnetic pulse. It's a pretty gnarly thing. I mean, electromagnetic pulses, you can blast a pulse at a platform and fry its onboard electronics so that it goes down. And the only thing I can say to that is pretty sophisticated technique. I wouldn't expect a normal individual or a typical individual to be able to do something like that. Perhaps there would be techniques, whether it's sophisticated shielding or something, I don't know, it's actually protected from that type of attack. But that would be a tough one to take out, quite frankly. I mean, it depends on the quality of the device that's being used and the power of the pulse. So it's a very variable situation. I'm sorry, the lady in the back in red, please.
Yeah, one of your early slides had what required registration as a drone, and it was like 0.55 pounds to 55
Yeah.
pounds. What is the limit? Why is there that limit on that max side? Does it fall into another category? I mean, somebody makes a 60-pound drone, what happens?
Yeah, I was worried about that question. I don't know.
Well, I mean, right? I mean,
I don't know why
kind
it's
of
at 50.
odd.
I don't know why it's at 50. I think it's because it falls over a whole nother threshold, which requires a whole nother deeper level of registration. For the registering of the small drones, you get the UAV, you pop it out of the box, you got the manufacturer and the serial number, you go online and you register it. If it's bigger than 55 pounds, I'm sure there's a much more detailed process that you have to go to register it. I think that's the threshold where you get into a whole nother realm of, so. If it falls into the category of over half a pound, it's gonna have to be registered.
Yes, there's a cost for it, $5.
$5, yeah. I think if you're flying it like in your house or something like, you don't have to register, but if you're going to take it and use it outdoors, if you put it up in the sky, you have to register if it's over half a pound. Sir?
Yeah, you mentioned that the airport lawyers were nervous about collateral damage if you're doing a drone.
Any civilian company anywhere is going to be nervous about that.
Did
But
anybody remind the airport lawyers about the possible collateral damage if an airliner comes down?
you know, I mean, that's the conversation, right? So it's the risk cost analysis benefit. It's a very complicated issue, and it's obviously, you know, I think given confronted with that kind of choice, anyone's going to do the right thing and deal with the lawyers, you know, deal with the legal ramifications later, because you don't want a commercial jet liner, you know, to go down. But you know, it's a very complex issue. Sorry.
So, this is in regards to registering the drone. If I want to fly it in my house, like I'm okay. But if I want to fly it on my porch, I got to register the thing. Or if I want to fly it in my backyard, I have to register it. Is that right?
I think unless you're flying, if you're flying it outdoors and it's above half a pound, I think you're supposed to register.
But do I have to register a kite? I mean, what about, where does
It's
it
not
stop?
that's not a UAV because it's not a motor and it doesn't have a commander. Ma'am, in the back, please.
Yes, if you buy one of these from Amazon, what's your expected life expectancy for one of these aircraft, barring any outside interdiction?
How long?
Yeah, how long?
How long do they last? How long does your investment last?
Yeah.
They last a long time. I mean,
Well, if we don't crash it, I mean, what kind of maintenance does it have to have?
Very, very little. I mean,
Oh, really?
these onboard engines, they're electric engines. I mean, they last years. Yeah, I mean, most of the damage comes from when you fly them into a building or into a tree, or you crash them. You're much more likely to lose your UAV from crashing it than it just running, you know.
Just old age, then.
From old age.
Okay, thank you.
Sir?
Two parts of the topic here. First one, registration. We know just by what we're seeing, a lot of the youth and students are not going to register.
Right.
And they're going to apply those drones. And a lot of hobbyists. You got issues between hobbyists, your regular drone fanatic, and the individual that is, you know, driving for commercial. Is there a solution for that?
No. I mean, I guess the answer is no. I mean, it's the guidance is put out there. I mean, it's the law is put out there, and it's just like any other law that's out there. I mean, the speed limit is posted at 70. How are they stopping you from doing 85?
So how do you register? I don't see.
I mean, I'm not trying to be glib about it, but it's a
I
complex issue. I mean,
I don't understand why registration, because I would think if you register a drone, the reason you're registering is so it can be traced back to you. How do you trace it back? I just crashed into the Empire State Building and I ran.
Right.
And and I registered that drone, but that drone is nowhere, there's no numbers on it, there's no IDs on it. But I did register it on Christmas.
Didn't put the sticker.
I didn't put the sticker on it.
Yeah, but you have to consider that this is all about public awareness, part of the public awareness, right? So, you know, the FAA is doing everything they can to get out in front of this, to make the public aware that, you know, the responsible flyers, just to put out, you know, flying guidelines. You know, registering your drone with the FAA is another level of, you know, responsibility that, you know, you're having to follow through on. Again, if you want to not follow the law,
But
I don't know how they're
you
gonna
have to
enforce
have
it.
something. Like, for example, if I'm gonna drive a car,
yeah,
I got a registered car.
Right.
What does the car get registered with? The police know if I leave it on the side, it belongs to me. If I get in a car accident, they know it belongs to me.
right,
If I sell it to somebody else, they know it belongs to me.
sure.
That's what I mean.
It'll depend on the UAV. Obviously, you could put together your own UAV with the parts you buy online, and then it definitely isn't gonna be tracked back to you. Some of the UAVs probably, you know, they have on, you know, they have serial numbers, and you have to register it. I guess it could be tracked back to you. It's gonna be, it depends on which type of UAV you lost doing whatever it is that you were doing. But, you know, I agree. I mean, if you wanna fly, you know, if you wanna fly a UAV that you put together on your own, there's no way to actually track it back to you.
How about the geofencing?
Right.
Because the geofencing can be turned off.
I know that.
And now that's another big
That's
variable you're
that.
pointing to.
But I think you're underscoring, you know, I'm not in the FAA, I'm not working on the side of the FAA. I'm just communicating that that's part of the overall complex story that we have here.
That's the FAA issue, right? That's what-
But, you know, I'm sorry, what was the last part of your question?
No, that's a big issue of the FAA. You're right on what you're saying.
Right. So my focus is actually working, you know, with clients, customers, large organizations, where we have to assume that the person who's flying it, they didn't worry about registering it, they're not worried about flying it responsibly, they're not even flying it legally. I have to operate and work with my customers with the assumption that every UAV that's out there is going to do something bad. And I have to help protect my customers to help them be aware of that as early in the process as possible and help them stop that from happening. I don't assume anything when it comes to that, because I can't afford it, we can't afford it. Everybody's gonna register, therefore I have to actually provide a system called drone tests. That's not what I'm doing. Sir?
Yes, as a person that has a 3-story home with a rooftop deck and a pool at, you know, ground level, one of the things that concerns me is noise, because living in this area, which is
Sure.
impacted by the McCarran aircraft.
Yeah.
And, you know, down at pool level, you know, even noisy motorcycles are not as obnoxious as when I'm up on the deck.
Right.
On the top of my house. And I would assume, has there been much addressing the noise factor that drones would be creating?
You know, in my field, because I'm trying to track them, the noisier the better, as far as I'm concerned. But you're right, and I think that the noise, I mean, to me, it's probably a taste thing. I mean, I think it's kind of a subtle noise, it's almost soothing a little bit. I don't know what manufacturers are doing, to try to restrict the noise. I frankly don't know. I'm not kind of working that part of it. I mean, it's a good concern. I mean, it should be. I mean, if there's going to be thousands or hundreds flying over your house, and the sum total of 100 UAVs dropping package is this constant buzz that sounds like, you know, I don't know what, then you have a legitimate concern, and honestly, I don't know what they're going to do about it. But it's a good question. Sorry.
Being a hobbyist, an RC flyer, I know for the registration, when you register, it's like a ID. You
Yeah.
get a number that you're supposed to put on the aircraft.
Mm.
But if you don't put it on the aircraft, there's no way to track it. Also, the AMA, the American Modelers Association, they have they do a lot of stuff for the modelers, which there's like a know before you fly education system out
Yeah.
there. So that, if you need to know get on there and check out the AMA website. It is very informative, and they're working towards trying to get it sorted out. Now, I fly from the North Las Vegas Airport flying field up near the Aliante, and there is restrictions for the noise and stuff of the planes. There's restrictions, time restrictions, when gas-powered planes can fly, time restrictions for when electric planes can fly also. There is a lot of restrictions, but it's not gonna do any good unless the person that purchased it actually follows the regulations.
Yeah,
Otherwise, you just regulate the people that's already following the laws.
Yeah, I agree, and then there's the enforcement part of that as well. Once they're flying and there's dozens of them, and the inside or outside of noise, parameters, then what's next after that? Any more questions? Sorry.
Yeah, I saw one of your examples of using multi-rotor drones.
Yeah.
I wonder if you deal with fixed-wing drones at all.
Yeah, that's actually a really good question, and the reason why we saw a lot of the focus on the multi-rotor drones is the vast majority of the drones that we're seeing out there that are causing an issue. Like every single one of those airport incidents, every one was a multi-rotor drone. Every single one. I personally, I'm sure it's happened. I personally don't know of any one incident on an airport where it's been a fixed wing drone. I think that the fixed wings and the gentleman's an expert here. He could probably tell you better than I. The fixed wings are probably a little bit more complicated to fly. The copters are so easy to fly. They're so available. So when you work in the business, right, you kind of gotta hit them where they are, right? So if the fixed wing is 3% of the problem and 97% of the problem is the other, you have to approach the problem where the density of the issue is, and that's why you certainly focus on the copter. Now?
I have a question. I was wondering, do we have defense capability if an organized attack of unmanned vehicles
Yeah.
were to attack an airport, any airport? And I'm going to say, I have no idea how many it would take, but if it was organized, would we be able to defend ourselves?
Ultimately, I think that the systems are there to help defend against the problem. I cannot speak for any one specific airport and their ability to actually do anything about attack, let alone an organized, a drone threat, or other than ones I'm actually specifically working for, let alone an organized threat. And if you're talking about multiple UAVs working as a swarm, like you were sort of mentioning, in there, I'd have to say probably not. That's why we're developing solutions like drone fence. So we're getting our arms around the problem. We're working with our customers. We're pushing the envelope as far and as fast as we possibly can to help protect the public, help protect these critical clients, customers, and government organizations to help get out in front of this issue. It's a very, very complex issue, and I think today I was trying to just sort of tee it up and talk about the breadth of it at a very high level so that, collectively we can kind of understand it a little bit more together.
Thank you.
Any more questions? Well, thank you. I love all the questions. You were really Well, thank you for being with me tonight on Saturday, and good luck tonight.
That was fantastic.
I don't think, it's a game changer. The whole thing's a game changer.
Oh, is that right? Well, they I'll be in Vancouver next week. I was just thinking about it, so didn't call. I don't know. If the person comes to Vegas again, it's not going to really break my heart. Thank you for coming tonight. I really appreciate it. All right, thank you. Hopefully you like it. All right, cool. All right, thanks, Pat. Thank you for your question. Good man. No, my parents lived up there.
Is this video record going to be available on
Yeah,
YouTube?
We might have like a brief part of it. Brief. Yeah, we usually do like the first 10 minutes of that. We're not sure if we're
Follow
going to
us
do the
on
full show.
Facebook,
But
Twitter,
well, we'll suppose it.
that's how you find
My brother in law
all the
ordered me here tonight.
Whenever we have an upcoming event,
And I'm sure right down his alley.
Well, let me give you one of my
Where to fly it and so on.
Nice.
Oh,